Hi, pals. Today we're going to be looking at another beautiful exposition, which is titled Molecular Formulas of Compounds. So, in the previous exposition, we worked on radicals and oxidation numbers, and we discussed how we could get them easily and how we could also use them to get our valences. So, today we're going to be using the knowledge of what we learned in those expositions to get the molecular formulas of different kinds of compounds. So before we go into this, if you've not seen the very exposition before this, I would love you to go ahead and see them, because it will be very tough for you to understand what we're about to take if you don't understand how to get radicals, valences, and oxidation numbers. Now, how do we write the molecular formula of this very chemical compound, this calcium triisocarbonate 4? Calcium triisocarbonate 4. Now, for us to write out molecular formulas, all we need is the valency of each of the major elements, each of the major players. So here we have two major players, which are the calcium and the triisocarbonate 4 ion. Now, triisocarbonate 4 ion is an anion, it's a negatively charged ion. So don't forget that for us to get valences are gotten from radicals and oxidation numbers. So what we just do is that we just assume that they are positive. That's what valences are. So for calcium, what is the valency for calcium? That's the first question. So calcium, which is Ca, has a valency of 2. That's that for calcium. Then triisocarbonate 4, CO3. Now, by the time you combine all this together, for radicals, we learned how to get radicals in the previous association. Now, the carbon, this one atom of carbon, 3 atoms of oxygen. By the time you do your calculation, you end up with that is 2 minus. So 2 minus is the same thing as just ordinary 2 for valency. So the next we do is to do this calcium, which is 2, CO3, which is triisocarbonate 4, which is 2 also. We cross multiply. What do we have next? We have calcium, 2 atoms, then CO3 here, the 2 will be here outside. So 2 calcium atom, then 2 triisocarbonate 4 atom. So the next thing we do, 2 can take out 2 here. What do we have? The CaCO3. This is a simplified version of this. So this calcium triisocarbonate 4. So this is how to write this very chemical formula. So question 2, this is sodium hydroxide. Now, how do we write sodium hydroxide? How do we write the molecular formula for sodium hydroxide? How do we do that? Now, don't forget here, we have two major players. Here we have sodium, combining with this hydroxyl ion. So first of all, don't forget that we need the valency for each of them. Each of them has a valency, so we need a valency. So sodium, which is natrium, Na, has a valency of 1. Don't forget, we worked on all this already in the previous exposition. So the hydroxyl ion, OH, has a valency of 1 also. We don't really care when it comes to valency. We don't care if you're talking about a positive radical or a negative radical. So the next is sodium right here, 1. So the hydroxyl OH right here. So we'll cross multiply. This goes with this. This goes with this. So that'll be Na, sodium. That's 1 atom of natrium, which is sodium, and 1 atom of the hydroxyl ion. So what do we have here? This NaOH. So I have to write sodium hydroxide. As simple as that. Example 3, silver trioxynitrate 5. Now, how do we write the molecular formula for this very chemical compound, silver trioxynitrate 5? Sometimes we call it silver nitrate. Now, the same thing we've done in the first 2 questions, and we're going to do the same thing. We're going to be using the same method. So silver first. Silver is argentum. Silver argentum is Ag. That's a Latin name, silver. So what's the valency for silver? Is 1. Silver is 1. Then trioxynitrate 5. The trioxynitrate 5, that's NO3. That's 3 atoms of oxygen, 1 atom of nitrogen. Don't forget that by the time we combine this together, we end up having -1. This is an anion, but we don't really care. You're talking about valences this time around. So that's just 1 also. So what do we do next? This Ag right here, 1 atom of it. This NO3, 1 atom of it. So what do we do next? We cross multiply. So 1 goes with this, 1 goes with this. So Ag, 1 atom, NO3 in bracket 1. So what do we do next? We bring it out this AgNO3. So this silver nitrate. Okay guys, here's the fourth and final example and how to write a molecular formula of compound. Now, this is iron 3 chloride. Iron 3 chloride. Now, don't forget iron, just like copper and a couple of other special metals or elements, have different or varying kinds of valences, So here we're talking about iron 3. We're not talking about iron 2. We have iron 2, we have different kind of iron. For this iron 3 chloride. So here we have two major players, which are the iron, which is ferrum, and the chlorine. So iron and chlorine are the two major players. So we're going to be getting their balances and we combine them to write this molecular formula. So first of all, iron 3, this iron 3 here, iron has a valence here. The valence you're talking about is 3, this iron 3. So this 3 for iron. So for chlorine, what was the valence for chlorine? Chlorine is 1. Chlorine, don't forget that chlorine is 17, as atomic number of 17. So by the time you write out the electronic configuration, 288, so we end up having 287 for chlorine. Needs 1 to become balanced, so chlorine is -1. That's the oxidation number for chlorine. So we don't really need the oxidation number, we just need the valency. So chlorine is 1. So the iron, which is 3 right here, 3, then the chlorine, which is 1, will cross multiply. This atom goes here, the other one goes to this other side. So that's that. So iron 3, chlorine 1. Iron 1, I beg your pardon. Then chlorine 3. So what do we have? This iron 3 chloride. This is how to write the molecular formula for this very compound. Okay guys, at this very point in time, it's time we got ourselves tested to see how much we've got from today's exposition. So here we have a couple of take home. So you're going to write me the molecular formula for this compound. So the first is iron 3 tetraisosulfate 6. Iron 3 tetraisosulfate 6. The next we have is sodium trioxynitrate 5. And after that, the third one, ammonium trioxycarbonate 4. And the very last one, zinc tetraisosulfate 6. So I would love you to write out your answers in the comment section. So at the very point in time, we're going to be drawing the curtain on today's exposition. So if you found this resourceful, please subscribe to this very channel and share this exposition. Thanks. See you in the next exposition.